Let's talk about these two things today. These are contactors, and this is not a sponsored video. I just bought the cheapest ones I could find because I did not know how a contactor worked before. And when I learned how it worked, I wired it up, I tried it, and now I want to put the type of video or the type of information on the internet so whoever is looking for a video on contactors can find one that's going to be straight to the point. We have two types of contactors. The one I'm going to talk about right now is what we call an AC contactor or a changeover contactor to switch between two sources of electricity so that it is uninterrupted. So what happens in a contactor is we would have, say that this is power source 1 and this is power source 2, and each one will give me an alternating current output, which is normal. I'm not going into the detail of whether this source of power is three-phase or not. We just know that they both give me an AC output, like what's coming into your house. So say that this is the grid power and this is your generator backup power. You would want to switch between these two. Now what happens when if I want to switch between them, and this is my house, this is my home, and this is what we can consider the load that's going to take in this power. So what goes into the middle here? For one, if we simplify it a lot, I can have a relay. I can very simply have a relay that will be in this sort of configuration. Okay, this is going to be my normally closed and this is going to be my normally open. And this is going to be the positive and this is going to be the negative. The negatives definitely have to be connected together, and the positive, one of which is going to go over here and the other one is going to go over here. Wait, hold on, this is normally closed. This is the normally closed one and this is the normally open one, because this is the one that's going to switch to the other side over there, and this is going to be the output. It's going to be plus and this is going to be the negative. Okay. I'm just going to get rid of all the scribbles so that it is nice and clear. Okay, so this is what I have. I have two power supplies. One, they're each going to give me alternating current, which can be like 110 to 230 volts AC. And one is going to go to the normally closed, which is going to be not a priority. And we will talk about what I mean by not a priority in a bit. And this is going to be the normally open, and this is going to come here. How do I switch to the normally open normally? How do I excite the relay when I want to deliver power through the relay? I will have a coil. Let us put that coil like this. And I'm going to have a positive and a negative with it, accounting for the freewheel diode that we will have. We will see how we will build this up in a bit. So when this coil is off, the normally open is going to stay open. It's going to be an open circuit. But when I turn the relay on, So let us put it here. So relay off, it's going to be like this. It's going to deliver the power. It's going to deliver the power of the normally closed. Once the relay is on, it's going to switch to the normally open. So I'm going to have the electricity passing through here instead of here. And the normally closed is going to be an open circuit, and the normally open is going to be a closed circuit. So this is when the relay is off, and this is when the relay is on. It's going to do that switching. Where does the power from the relay come? Normally, when we are talking at an electronics level, it will be from a 5-volt signal through a transistor to power it up. When we are talking about a contactor, there is also a coil in the contactor. We will talk about the structure of the contactor, and you will then put together how everything is going to work. So we can see that it's just going to be one thing switching over from the normally closed to the normally open. This is like the very basic level. Let us take it to a high current application, a higher power application to actually power a home. So what we would need is the contactor. The AC contactor is going to have 4 screw holes. 1, 2, 3, 4 on the top, and 4 screw holes at the bottom. These are where my wires are going to go in. What's inside is we have many smaller relays. I'm going to have a relay over here, and I have another relay over here, relay over here, and a relay over here. Okay, so what's the difference? Except the 2 ones in the middle are going to be normally closed or normally open. It depends on what you buy. They are going to be normally closed, and these ones will be normally open. There is going to be, these are all mechanically connected to each other. So if I excite the coil, they will all close. If I de-excite it, de-energize it, it's gonna be off, and these will switch. So when the coil is on, these two will close, this one will open. When the coil is off, it will go back to these are closed, these are open. It will do that quickly. There's an electromagnet inside. So I'm gonna have the coil sitting right by over here. When I was talking about the priority that I want to set, didn't we say over here that when I excite the coil, it will switch over? Whatever I connect to the coil, the power supply I connect to the coil will establish my priority. So if I take the generator power supply and I put it onto the coil, the generator is going to be my priority. Whenever the generator turns on, the contactor will switch. And if I put the grid on the connected to the coil, which we will see how we do it, the grid is as priority, which is more preferable because you can consume more load. You can consume more current from it. So how do we wire this up? What we are going to do, the 2 middle and the 2 out are where we connect the 2 different power supplies. So we have 1 and 4, which will be for the power supply that's, say in this case, the generator or the grid's power supply. This is going to be positive or negative, interchangeably, because we're talking about AC, but to make it clear. The middle two are going to be connected to the backup, whatever it is, depending on the contactor as well. So these two are going to be in the middle, over there, and they are going to be connected to the generator, positive and negative AC. So that's how we connect the both of them. When the electricity provider wants to cheap out, because normally the grid is going to give you a live and a neutral. The generator will give you a live, but they might piggyback on the grid's negative. So instead of having it like this, an extra wire, what they might do is they might take a jumper and bridge these two together so that they don't have to extend another hundreds of meters of wire. They only have to do it once. So this is the input side. Now for the output. I want to get the output uninterrupted. So what we do is that we take this one, we short it together, and take these two, short them together. This is the negative, and this is the positive. And this is what will go to my load. That's what's going to go to my load. The positive and the negative of the output. And here we have the 2 and 3 prongs. So let's take a look at the contactor. The AC contactor is going to be a bit bigger than the other one, than the three-phase contactor. They both take AC current. So this one, in my case, AC contactor, it is compatible between 220 to 230 volts, 50 to 60 hertz. Excellent, and it can withstand up to 40 ampere. We have 4 poles. These are the 4 poles that we were talking about. We have 2 open, normally open, and 2 normally closed.